So I want to take a look at the question. Let me get my pen rolling. AC, I think it was greater than or equal to BC. So the problem here is we don't have direction on what C is, right? So it's possible that C could be a variable. And if I divide both sides by a variable, I lose my solution, right? I get 2 is greater than or equal to 3. This is the same mistake as when we had a squared was greater than a. I can't divide both sides by a because, again, you're losing a solution. This should have 2 solutions. This should have 1 solution. So by dividing both sides by c, you're potentially coming up with something that's algebraically incorrect. So a better way to do it would be if I say, okay, suppose, so let's just suppose for a minute that A is less than B, right? A is less than B, that's my given situation. If I take A and I multiply it by C and B and I multiply it by C, then this is a true statement. AC would be less than BC. And you could even give a little example. You could say A is 2 times 4 is less than 5 times 4, and you can see that this is going to be true. So this would be, you need to put this in your nice little proof formatting, but this is a better way to look at this proof. I didn't take off points because I felt like with A, B, and C, it may not be totally clear that you couldn't divide there, but I definitely wanted you to take a look at this premise to proving that proof, which is why I sent this video, and being careful to not losing a solution by dividing by a variable. So be really careful with that algebraic concept as you're working in your proofs. There is more than one way to get to an answer in a proof. So take some time and make sure you're asking yourself, if I replace this with numbers, and an x, can I do what I just did? That's a great way to verify what you did in your proof is algebraically correct, is to go ahead and plug in some numbers and try it out and say, can I divide both sides by x? So most of us are going to look at this and say, no, I can't really do that. I need to subtract 3x over, or I need to do something else. So that may help you a little bit with these proofs and seeing what's necessary.